Sri Gurubhyo Namaha children, we welcome to our online learning initiative Ekalaiva. I think last lesson was very useful to you to learn through this video, no? Shall we see that with the second lesson? Our second lesson is, name of the lesson is motion. With that, going to see what is the motion and rest so many topics you are going to learn through this lesson. First, you know what is motion. Okay, now I'm in which position? If I move over here and then I am come back over the same position. So what happened? There is a change in position. Okay, with respect to my surrounding. So in the classroom I cannot go out. So this is my surrounding. I am changing my position between here and here. Okay, the change in position with respect to surrounding. An object, the change in position with respect to surrounding is called motion. Understood, children? Motion means the object will keep on moving. Okay, with the respect, if it is any car is going on the road, it will run on the road. It will not run inside our room. Also, with respect to surrounding, it will move, change its position. This is called motion. Okay, from one place to another place, an object moves. So that's a change in position, no? Isn't it? So that change in position of an object is called motion. Motion means change in the position. To be change in the position of an object with respect to its surrounding. With respect to surrounding, object will change its position. It is called as motion. Okay, do you understand what is motion now? So all the objects which are in the universe, all the objects are in motion. Okay, so the object which are in motion at one particular point, what will happen? It will take some rest, which means there is no change in position, isn't it? See that, going to see now. Everything in the universe is in motion. For example, car along the road, trains along the track, aeroplanes in the sky, fan rotating in the ceiling and playing in the swing are all different types of motions. As I said you, motion means there is a change in position with respect to surrounding. Around us everything are in moving position, no? So the moving position is called as motion. Okay. Now, so there is a difference. The object which are in motion, definitely it will come to rest, which means there is no change in motion is called rest. So motion and rest, which means an object change in position from its with respect to its surrounding is called motion. There is no change in the position is called rest. So between this, there is a force is applying between this. No, when we apply a force only, it will move. The object will start move. So when it start moving, that object attained a motion state. Okay, so the same object, if you apply no force, it will be there where we left it. So that means no change in position. It is called rest. So do you understand the difference between motion and rest? Now motion is describes in what are the terms? No, it can describe in the terms of speed, distance, acceleration and time. So in this way we can represent the motion. With respect to speed, it will show its changes. With respect to distance from one place to another place, there is changes is happening to the object, no. So with respect to distance also can represent the motion. Then acceleration, we'll see what is speed, distance, acceleration type one by one through this now. So with respect to all these things, we can represent the motion, which means object will change its position from one place to the another place with the help of force or any other forces will apply to that. So as I told earlier, there is a difference between motion and rest. So rest means object do not change their position. If there is no forces applied, the object will be in the same. If you keep a book on the table, until you go and take it, it will be there on the table. Automatically it will not move from away from its place. So what is happening there? It is in rest position. An object change their position. Okay, if you apply a force, it will change its position. Even your cycle, No, until you take and ride it, it will be there where you left to park it, isn't it? So this is how the motion and rest are different. So examples of a rest means a book lying on a table, the walls of the room, all the walls around us, no, it is there until, even if you come and see next year, it will be there in the same position. There is no changes. Okay, so there is no changes in the position of an object is called rest. Motion means, see, cars and buses running on the road, birds and aeroplanes flying in the sky, these are all motion. So when it want to move, there is a changes. Okay, keep on insisting the word changes. So changes will happen to an object is called motion. No changes, do not have any change in the position is called rest. Understood? What is the difference between motion and rest? Now we are going to see. So you know what definition about what is motion and what is rest. Okay, so types of motion. So what are the types means? Linear motion, circular motion, oscillatory motion, uniform motion and random motion. We are going to see this one by one gradually now. First, linear. Linear means straight. Okay. See, linear motion means movement along a straight line. If you see the picture, the boy, when a boy is running, he will go run in a straight line only. It will not move it by the zigzag way, isn't it? So when an object move along a straight line, that is called linear motion. Linear means straight. Next, circulatory motion. Okay, you know all the motions means there is a changes. No, so an object will move in a circle way. Okay, it will move along in this circular position along a circular path. Okay, even merry-go-round will go, it will move on, go around. No, so how it's moving? It's moving in a circular way. No, so that is called as circular motion. So linear means motion along the straight line. Circular means, the word circular means around. Okay, so it will move around the things is called as circular motion. Next, oscillatory. We used to play in our even now we used to like to play in the swing. What will you know? When you moving in a position 2 means the same distance you will cover when you go back also. So movement to and fro. Okay, an object will move to and fro. To means going front. Okay, then moving back, front and back, and then retracing its path, which means equally cover the distance which moving front, the same distance it will cover in the back also. So equal distance covering both front and back. So that type of motion is called oscillatory motion. Best example is swing only. Okay, an object describes to a repetitive to and fro movement. Repetitive means only once it will not move until the force which apply on its swing, it will keep on moving. No, that too it will cover a distance. If it when it cover towards this my left side here means the same distance will cover in the right side. So equally covering a distance with move front and back. This is called as oscillatory motion. Linear, straight, the motion along only in a straight line. Oscillatory, in a circular path. Sorry, circular is circular path. Oscillatory means to and fro, movement by taking place to and fro. So to and fro means when it's moving front and back. Understood, children? Then uniform motions. Okay, so uniform means, listen, an object travels equal distance in equal interval of time. See the word I am using. equal distance in equal interval of time. Okay, so this is called uniform motion, which means distance and time both are equal. 5 minutes, if you are able to reach 1 kilometer, means next to 5 minutes you should reach the next same. Okay, 5 minutes 1 kilometer, 2 minutes 10 minutes 2 kilometer. Likewise, the time and distance are covering equally. It is called as uniform motion. Okay, so an object travels equal distance in equal interval. So distance and the time both are in equal, means then that type of motion is called uniform motion. Then obviously when this is any one is vary. Okay, time is equal but distance cannot cover. Okay, for example, from your home to reach a school, normally you will reach a school 10 minutes, means that 10 by next day if you cannot reach time 10 minutes, but distance due to traffic could be there in the traffic itself. So what happened? Distance cannot cover with the time. So what is happening? Distance and time become unequal, isn't it? That unequal is called as the non-uniform motion. Okay, uniform means time and distance both are equal. So non-uniform means object motion covers unequal distance. See, unequal distance but equal interval of time. Same time, there is no change in the time, and the same time. See, if there is a particular time, is you will get the graph towards like this. If there is a changes, means see, so there is a changes in the distance. It is with respect of a time. So time is same but distance is vary. This is called non-uniform motion. Random. So far we seen about what? Linear motion, circular motion, oscillatory motion, uniform motion, non-uniform motion. Random means it will not get into any point. It can move. If you see the picture, see that there is a circular path, elliptical path if it come along this side, it is straight line. So this is the way it cannot fix with any motion. That is called random motion. Okay, the objects not fall any of the above categories is called the random motion. So next, we seen so far about what is motion and what is rest, difference between motion and rest. What are the types of motion? Linear motion, circular motion, oscillatory motion, uniform and non-uniform motion, then random motions. Okay, all these will shows what? There is a changes in the position, no? So that going to see the next topic is distance and displacement. Actually, you have to keenly observe and know the difference between distance and displacement. Let me read and tell you this. The actual length of the path travelled by a moving body irrespective of the direction. So actual length means normal from here to there. Okay, from this corner to that corner, this is the actual length. To reach the corner, I can move. For example, from here to Chennai, I want to travel, means this is the going by train, going by car, going by bike. So three different vehicles we can use. So to reach Chennai is okay, but can go any other way to reach Chennai, isn't it? So what is the distance is changing over there. So the actual path from here to Chennai can go by train is one way. So what will happen? That is called distance. See, irrespective of any direction, what happened? Some kilometers may be vary. If you go by car, some kilometers will be lesser for you. If you go by train, extra time will be taken place. Okay, but what is happening? You are reaching the place exactly. So go from one place to other place, the actual path is reaching with irrespective of any direction is called distance. So displacement means it is defined as the change in position of a moving body in a particular direction. Any direction you go, okay, that is called irrespective of direction. if you go and reach the place is called distance. Particular direction only is taking place to reach the place is called the displacement. Okay, let me show you the image. See now example, here I have taken, this is a point, this is a point. This is the path. Okay, a person this is the path a person has to move from here to there. Okay, to now what he is doing, he can move along this side and that side and reaching the target. So what is happening? There is a way directions are changing. No, this is called distance. Finally he reached the place, but what happened? Changes in direction, he has gone in any other way, but finally he reached it. So what happened? This is called as distance. Same path, a person reached along the straight line, along the path, same path itself, only in the towards one particular direction. See, this is called displacement. Understand? So changing in direction, moving the actual place is called distance. Without changing any way, not move anywhere else, go in only a particular direction. This is the way to go, means that is the way to go and reach a place is called the displacement. Understand between distance and displacement, children? So far the motion is applying everywhere. Changing in position, no. Changing in position is taking place in all the things. I told you, in the motion can read in terms of speed, velocity, acceleration and time, no. So with that going to see speed. So speed means, speed is the rate of change of distance or distance travelled by a unit of time. Okay, speed will show you what is the distance. Okay. So a scalar. Scalar quantity means it is having a magnitude, no particular direction. That is why it is called a scalar quantity. Speed will show you the distance, how speed, how fast, how slow. That only it will represent. It will represent change distance travelled by a object in a unit of time. 1 hour, how many kilometers the person has reached. So it will show you how fast. Okay, 1 kilometer, 10 minutes is gone means how fast the person has moved. So it will tell you the fast or slow. So with the respect of distance with the time taken, this is called speed. Okay, so the SI unit of speed is meter per second square. So it can represent by distance travelled by time. No, distance can measure by meter and time can measure by with this seconds. So that SI unit of speed is meter per second. So this is called speed. Speed is what ma? The rate of change of distance or distance travelled by unit of time. It will tell you how fast or how slow with respect to a time and cover distance. This is called as speed. Next is velocity. So what is the difference between speed? No, along with the fast condition, slow condition, it will tell you the directions also. That is why it is called as vector quantity. Okay, velocity is the rate of change of displacement. You know what is distance? Speed will tell you with the respect of a distance. Here velocity is the rate of change of displacement. You know the actual path is moved, okay. With the displacement means it contains a direction, only a particular direction it will move. So that it is called as vector quantity. If there is no direction, it is called scalar quantity. It will have only the length, size alone. Vector quantity means along with the size or length, it will show you the direction. That is why this velocity is considered as a vector quantity. The SI unit of a velocity is again meter per second, because velocity can defined by the displacement by time taken. To displacement means, so if this is the actual path means, so to take a time taken from here to here, what is the time, and time taken to here, what is the time. So it will calculate the displacement time with the velocity. Understood, children? Velocity means it will tell you, it can calculate the displacement by time taken. The SI unit, again the displacement can measure with the help of meter, time can measure with the help of second. So meter per second is the SI unit of velocity. Same SI unit for speed and velocity. Speed is distance by time, velocity is displacement by time. So next going to see. These are the examples. So what is the displacement, distance and displacement is taking place. Next, third is the motion can represent the name of acceleration. No. So acceleration means the rate of change of velocity. See this. Change of velocity, which means there is a displacement in the changes. No, velocity means change of displacement. So there is a rate of change of velocity is the with respect to a time. So again vector quantity. What is the vector quantity? It will show you a direction. Change in velocity, which means it shows there are changes. Initially some velocity will be there, after reach the place there is some changes will be there, isn't it? So which means 2. Initially the object will not move anywhere, so we can call it is a 0. So you can call the initial velocity u. I am saying about change of velocity. How the changes can find means through the initial velocity. Initial velocity can represent with the symbol of u. Final velocity. V. So between these only going to find change in velocity. After finding the changes in these two velocity, we can find what is the acceleration. Now, so this acceleration can take in the positive acceleration, negative acceleration. I told you there are two velocities, initial velocity and final velocity. Initial velocity can represent by u, final velocity can represent by v. How do we can consider a positive acceleration? Means if final velocity, okay, final velocity, which means v, is greater than the initial velocity. Okay, initial velocity is u. So the velocity increases with time and the value of the acceleration is positive. Okay, so in final velocity after reach, when you start ride a bike, the speed will be increased more. No, initially it will start slow, where then finally it become more and more. We will start with the gradually 20, 30, 40, 60, finally reach the 60. No, the same way. So the time also has been increased. So initial velocity is greater than the final velocity with respect to a time. So what happened? Time is also increasing. So this is a way when it is increased. When the velocity increases with the time, the final velocity is increases with the time is called positive acceleration. Okay, again same final velocity. Is less than, okay, less than the final velocity is less than the initial velocity, what happened? Time is also decreasing. Time is getting reduces. So this is called negative acceleration. So negative acceleration we can call as retardation also. So this is how the velocity change in velocity will take place, and I can finally find the acceleration. When there is no changes means v equal to u. We can represent. So final velocity is greater or final velocity is lesser. With that we can find the positive or negative. When there is no changes, what will happen? No, v equal to u, which means both final velocity and initial velocity are 0 and equal. Understood? This is how we can find the acceleration. Okay, we'll see you the next topic, children. Thank you.